Okay, we are continuing our section 1.1, and I want to do an example with you that you'll see problems like this in your homework. But let me just one moment here. Whoops. Okay. What we want to do is we want to verify that, and I may have to make this a little smaller actually. Hold on. Okay. We want to verify that the family of functions given by this P function is a solution to the differential equation below. Now, I'm gonna walk you through this, but I think for taking notes, it would be good to take notes on this particular problem. So I'll move accordingly. How many feel taking notes is helpful for them to learn? You learn by writing. Ekaterina knows what I'm talking about. Absolutely, she agrees. And hold on here, some other folks too. Let me bring up the chat. Daniel does. Great. Jared does. Han and Amanda, Matthew, wonderful. Sherman, great. 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 Leor, wonderful. Wonderful. So this is great. This is great. So now what I'm going to try to do also, I've been working with this. I have in my Adobe, I have a pen here that I can use. But every time I draw on it, it brings up a dialog box. And I don't, sometimes it brings one up, sometimes it doesn't. I don't understand why. I don't know if any of you have any knowledge about like using the pencil in like Adobe Acrobat to draw or circle things, but I don't know why it's drawing a dialog box around there. You know, I don't know. If you have any thoughts on that, I'd be happy to hear it because hear from you, you learn from you because it's like this is a great thing, except it draws those blue dialog boxes. And not that it's a big deal, but why does it need to do it, you know? So, all right, so that differential equation that I've circled in red, that is a logistic differential equation. I don't know if you remember logistic differential equations in Calculus 2, they were optional, but it's a differential equation that some of you might have seen before. And if you use the separation of variables technique, if you use that approach, you would be able to show that the solution to the differential equations is given by this particular function. See, now it doesn't draw the dialog box anymore. So, of course, to solve that differential equation, you'd have to use the separation of variables technique, which we'll get into next week. And, you know, it would involve partial fractions and stuff like that, which we'll be getting into. I mean, everything you've learned in Calculus 2, you're going to apply here. But right now, all we want to do is verify that that function P of t is the solution to this differential equation. Okay, so what we're going to do here is we're going to differentiate. Well, hold on. Let me make sure. Yeah, we're gonna take this function P and differentiate it and see if we can get the differential equation below. So here we go. Okay, so there's our function P, and we are differentiating it. Let me get that pen back. Thank you. There it is. So here, naturally taking differential equations, we assume that you know your derivative rules. And so we are using the quotient rule here, right? Quotient rule. So if you use the quotient rule, well, that's what you see. So quotient rule, let's see if I can maybe write it here. Okay, the derivative of a product f of f times g is f prime times g plus f times g prime. And this is what I have below. What we want to do is rewrite this expression. We want to rewrite this expression here so that it equals p times 1 minus p. Because the differential equation is dp dt is p times 1 minus p. So, okay, what we do is we take the derivatives. We have two derivatives here that we need to take. We take them and we end up getting this expression. And then we just do a little more, we're going to use the distributive property here to multiply C1 of E of t times, we're going to multiply it through this binomial. And similarly, we're going to multiply this function through this binomial. And in the end, we end up getting C1 times E of t over the denominator, which is the quantity 1 plus C1 of E t quantity squared. Now, please let me know if you have any questions on this. Lior, the reason we are taking the derivative is that they told us that we had our differential equation dp dt equals p times 1 minus p. So if this function p of t is actually a solution of the differential equation, then if we take the derivative of that function, we should show that the derivative equals p times 1 minus p. Okay, sure. Okay, so all right, so what we can do is we can take that and take our derivative and actually split it up like I do here. I can actually split it up. Now, why would I want to do that? Why would I want to do that? Well, it's going to allow me to show that the p dt equals p times 1 minus p. And in WebAssign for these kind of problems, they have a lot of it's very guided in terms of like what they in terms of this. The whole process is very guided. And but what's important here for this part is I mean, this here, this part here, let me just see here. Can I change my color to blue? Oh, it changed the whole thing. I thought it would. Hold on. Now I'm getting into some weird stuff here. Hold on. All right, one moment. Let me go back to the pen. I have not used Adobe Acrobat Reader before for doing things. Usually I use the Blackboard, but there are good reasons to use this. You know, I'm going to practice a lot more with it. It's just sort of today I decided to use this, but I'm actually liking it already because for one thing, you get to see it sort of, I get to move through the problem like I would like if I were writing it on the board instead of like giving you all the notes at once. We do it part by part. Amanda says she wants to see the quotient rule again. All right, one moment. Let me go back to that. Give me just one moment, class. Let me go back to that. This is the quotient rule here. The derivative of a product, f times g, is f prime times g plus f times g prime. Okay, very good. So let me go back down here. Okay, so what we can do here is pull that up a little bit more. Okay, what we can do is this part here, I have to show that equals 1 minus p. I have to show that that equals 1 minus p. So that dp dt is p times 1 minus p. Oh wait, hold on. Are you able to see the PDF or on the screen? Did we lose it? Are you seeing a blank screen, everybody?
It's not there.
Okay, all right. Hang on. Let me get it back. This happens occasionally. This happens occasionally. One moment. One moment. This has happened before. Let me bring it back. Hold on here. Okay. Okay, it's back now. Okay, wonderful, wonderful. Okay. So the second part of that product, 1 over 1 plus c1 times e to the t, you can take the 1, the numerator 1, and write it as 1 plus c1 e to the t minus c1 e to the t. And then you can rewrite that fraction as the difference of these two fractions. And this and what is this here? What is this here? Well, this is just equal to 1, and this is just equal to p. This is just equal to p, and this is just equal to 1. So it's a way of verifying. When they tell you that you have a solution to a differential equation, you can verify that it's a solution by actually differentiating the solution and showing that, in fact, it gives you the differential equation. And that's what's going on. That's what's going on. So are there any questions on that? All right, while you're finishing that, let me just check one more thing here. So I think that's pretty good for section 1.1. If there are no other questions, then I'll go ahead and stop the recording. And I want to give you a little chance to get into WebAssign and open up the first assignment. So let me go ahead and stop the recording. Thank you.